I am on the Docker documentation page for Docker Hardened Images. Docker describes hardened images as minimal, secure base images designed for production workloads. In very simple words, these images are built to have less stuff inside, so there's less that can go wrong. That's the whole idea behind Docker hardened images. If you work with Docker in production, consider subscribing. On this channel, I explain real DevOps problems in a simple way. Why hardened images exist? Most Docker images are built to be flexible. Docker hardened images are built to be predictable. Less flexibility, but more safety. And that trade off matters a lot once your application reaches production. Let me show you a very common Docker file that many teams even use today. This Docker file looks perfectly fine. I've seen this exact pattern running in production many times. Nothing here looks insecure, but this single line from Python 3.10-slim already decides a lot of things for us. If you are new to my channel, then definitely you have to watch this Docker Home Lab series where I try to explain each and every line how things work in Docker. If you are new to my channel, please also after this video go and watch that series if you are interested in learning Docker. Alright, let's build this image real quick. So I'm going to run docker build command as usual, -t demo python. I would give it as simple here. Press enter. Our image is ready. Now I'm going to check that particular image. For that, I'm going to say docker images pipe grep demo python. Press enter. If you see, we just tried to build this demo python simple and its size is 200 MB. This is the image most teams would ship without thinking twice. Now, let me clear the screen. Now, I'm going to run docker history command to check its history. I'm trying to pull out only the first 15 lines using head command here. Press enter. If you look at the output, if we look at the output, what you are seeing here is a mix of layers. The top layers come from my application. The bottom layers come from the base image. Most security issues that scanners report usually come from these base image layers, not from the code I wrote. This is my entire application code. It's just a simple Flask application, returns a string. There's no OS access here, no shell execution, no system level logic. So, if we see security issues, they are clearly not coming from this code. Now, I'm scanning the image using Docker Scout now. Press enter. Look at the packages being reported here. Things like pip, glib, core utils, OpenSSL, apt, all these are being reported. These are system level packages coming from the base image. My Flask application did not install any of these. This is inherited risk. This is exactly how recent supply chain attacks happened. No bad commits, no failed pipelines, problems entered through dependencies that got baked into Docker images. The system worked just against us. Docker hardened images exist To reduce this inherited risk, they remove unnecessary system tooling. They reduce what's present by default. Less inside means fewer vulnerabilities to begin with. Now, let's go to my Docker Hub personal account. Here, I logged in using my personal credentials, and I'm trying to select this Python 3.10.x version and click on use this image, copy this Docker pull dhio Python 3.10 and jump back to my Visual Studio Code, clear the screen, and I would like to run Docker pull dhio Python. Press enter. If you are doing it for the first time, definitely it is going to fail as usual. 401 unauthorized. I need to log in before I pull the image. For that, I'm going to copy this command from here. Docker login dhio. Press enter. Press enter, and I'm going to give my token which I created few minutes ago. So I'm going to paste my token here. If you don't know how to create token, I'm going to share with you real quick. So this is the place where you create personal access token. So just click on generate new token and give the token name, expiration date, and the permissions you want to give here. And click on generate, copy that and save it for your future use. We logged in successfully. Now let's try to run that command once again. So I'm going to go back to my browser to copy this command. Come back here, say docker pull, press enter. So we have the image locally. I just pulled, I guess, few minutes ago. So that's why it is saying image is up to date. That's fine. Now let's try to scan that. So for that, I'm going to copy that command once again from the official documentation. Copy this and paste it here. Docker scout CVEs dhio Python 3.10. Press enter. Scanners show you what's wrong. Docker hardened images reduce how many things can go wrong before scanning even starts. This is prevention, not cleanup. If we look at the output, no vulnerable packages detected. And here everything looks green and I don't see any kind of errors or packages. Now we have more trust on the image which we are going to use in production. Python 3.n dhio is the Docker Hardened Images repository. You don't need to be a security expert here. Just remember this. What your application runs on matters. Even a simple Flask application like this can inherit securities from its foundation, that is our base image. If this video helped you, please like, share and subscribe. I'll keep explaining real world DevOps. Thank you for watching and see you in the next video.